tonight, please raise your hand. Yes, Griffin. 11. Okay, I'm going to do 11 quickly. So on this problem, these are exponential functions, and we start by graphing them by selecting our h value in our table. And what is the h value, Griffin?
2.
The h value is, k is actually 2, h is going to be 1. Because it goes, I'll rewrite this, the form is, the form, exponential form, is y is equal to a times b to the x minus h power plus k. Do you see that? So h would actually be 1 here, and we know when h is 1, the k or y value is 2. So we pick a number less than 1 like 0 and a number greater than 1 like 2, and we plug both of these in. When we plug in 0 for x, that's going to give us 1/4 to the negative first power. And anything to the negative first power is what? It's just the reciprocal, right? So it's actually going to be 4 plus 2, which would give us 6. And I'm sorry. Oh, yeah. 4 plus 2, which would give us 6. And this is actually 3. I'm sorry. When we plug in 1, that would give us 0, and that's 1 plus 2, which is 3. Any questions there? Do you have a question? Okay, so when we plug in 2, what do we get, guys? When we plug in 2, what did we get? Jada, when you plug in 2, what did you get? Okay, so that would be 2 minus 1 is 1. Okay, so then we have 1/4 plus 2, which is 2.25, okay? Guys, I want to clarify something really fast because I think I misspoke. 1hk is not going to be a point on our graph for these exponential functions because k is our asymptote, which means we're never going to get there, right? So I should have, when I selected this 1, I needed to plug it in here. And then I'd get 1 minus 1 is 0. 1/4 to 0 power is 1, and 1 plus 2 is 3. That's how I got the 3 there. Is that clear? John Andrew, do you see that? So what's our horizontal asymptote here? Would just be y equals what? Yes? No, it's not. This would be y equals what? 2. Very good. And then we can graph these 0, 6. Okay, so 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. And then we would plot the point 1, 3, and 2. Hey, how are you? Good to see you. 2.25. So 2 and then 2.25, okay? And then our horizontal asymptote y equals 2 is right here. It's a little bit lower than that. Okay, and then we're just going to connect these points and graph this, right? And do you see how it kind of levels out? Not like that, but levels out here. Can you all see that? Okay, our domain is not restricted, negative infinity to infinity, and our range is 2 to infinity, but it doesn't include the 2, does it? Any questions? Any questions? We have a lot of different graphs, so I really need you guys paying attention and with me on this, okay? All right, so any other questions from the homework? Any questions on the on the logarithmic, the log graphs? Questions on logs? Yes, ma'am. 14. Okay, on 14, guys, remember we've already talked about this, how we can rewrite this as 5 to the y power is equal to x. It's in log form and we're writing it in exponential form. And remember we picked the points -1, 0, and 1 for our y because we're here, okay? And then what we would do next is we can plug these in, and if we plug in -1, we see that we get 1/5, right? If we plug in 0, we see we get 1, and if we plug in 1, we see we get 5. Or we can just know that every time we plug it in, it is just 1 over the base. So on number 13, what's the base? 6. And then it's just the number 1, and then it's the base, and that's 6 here. Does that make sense? And we learned about that when we learned about graphing log functions, okay? So now we need, you can write this as a decimal. This would be 0.2. I think you probably prefer to write it as the reason I wrote it as a fraction was so people could see the 1 over the base. So now let's look at our shifts, okay? What are our shifts? How are we shifting, Alexia? Alexia? Okay, down 3, that's a shift. And what else? Perfect. Left 1, down 3. That means we subtract 1 here. So this is going to give us negative 0.804. And then over here, we'd subtract 3. So that's negative 4, negative 3, and negative 2. Any questions so far? We just applied those shifts to our graph. So now we're just going to plot those points. Negative 0.8 and then negative 4. 1, 2, 3, 4. 0, negative 3. 4, 2. 4, negative 2. Okay, what is our vertical asymptote? X equals negative 1. Perfect. All right, so we're going to graph this vertical line. All right, and now we are just going to connect our points. Are there any questions so far? Domain is going to be, now our domain is restricted here. The lowest we can go is negative 1, so it's negative 1 to infinity. But are there any restrictions on our range? No, our range is negative infinity to infinity and beyond. Any questions? I'm sorry. You're right. Are there any questions? All right, can we move on to the new to stuff we haven't, or do you think we're good with what we covered on Friday? Okay. Yeah, we're moving on. All right, let's go to the back. Now, guys, remember we've been doing this on these previous problems. How do I write this expression how do I write it in exponential form? Do you guys remember? How do I do that? 5 to the x power is equal to 25. Very good. Now, when we do these problems, what we want to do, and you guys really hated this, we want to get the same base. So what do you think the common base is going to be? 5 is right, okay? Hannah, so how could I write this with a common base? We want our common base to be 5. Okay, how do I write 25 as a base of 5? Base of 5. So we would just say 5 to the what power is equal to 25? 5 to the second power. Good. Continue. So when our bases are equal, then we can just set our exponents equal, right? Our bases go away and we just have x equals 2. And we're done. Not so bad?
Not so bad.
Now, I'm going to ask you a question. This is my hint to number 18. Anything raised to the 0 power is? Good. That's my hint. So let's set this up. 3 to the x equals 1, and so x must be what? 0, right, Sam?
Mm-hmm.
Sam, on number 19, how would I set that up? Okay, time out. You have a question? 1 second, Sam.
Okay.
Go ahead. X has to be 0 because 0 is the only number we can plug in for x to make 3 to the 0 power is the only thing that's equal to 1. Like the 3 to the power of 0 is the only thing that would make that equal to 1. But anything raised to the 0 power is 1. Okay? All right, Sam, number 19.
16 to the x power equals 4.
16 to the x power is equal to 4. Okay, now how do I rewrite this, Sam? Same base. What would a common base be between these two guys?
4.
Okay, so I could write this as 4 to the...
Second.
But there's still the x, right?
Yeah.
Is equal to 4 to the first power.
Mm-hmm.
Now these guys go away and we're just left with our exponents, which is 2x equals 1. Divide by 2 and you get x equals 1/2. Any questions here? Any questions? Okay, what about on number 20? How would I set this one up? Could you help me please, Patricia? 2 to the x power is equal to 1/8. Okay, now this one's a little hard, right? So we want to write them as common bases. One thing we know isn't right at the beginning is one's a fraction and one isn't, right? So how can I get that 8 in the numerator? Well, I could I write it like this as 8 to the negative first power? Is 8 to the negative first equal to 1/8? Okay. Now, can I rewrite 8 with a base like 2? Can you? Is 2 to the power of something 8? 2 to the second power would be 4. Right? So we could rewrite this as 2 to the negative third is equal to 2 to the x. Do you see how we did that? And then our bases go away, and we have x equals negative 3. Raise your hand if you have a question. If you are bored with me right now because you understand this, please work on this and get this out of the way so you'll have less homework. Or if you've already done this, please work ahead of me, okay? You're going to find out what the homework is today at about 1:10. Okay. All right, so look on number 25. Guys, it says to expand. This is where we have to like break this up and write them as separate terms. Please remember that when we multiply, we represent that using addition, and division would be subtraction. So we can rewrite this as the log base 3 of 4 plus, what happens with the exponents? It goes in front, very good. 3 log base 3 of x plus 11 log base 3 of y. One of the most common mistakes you guys make is that 4 out front, you want to keep it with the x, and it's different. It's a separate term, so write it separately. Is that clear? Do you have any questions? Okay. Look at number 26. On number 26, how can I rewrite this? 3 first, right? Minus. We have the square root of y, so square root of y is equal to y to the 1/2, right? So then we'd bring that 1/2 out front, say 1/2 log base 2 of y. Do you see that? Any questions? I'm sorry? Any questions? Any other questions here? Do you think y'all can do 27, 28 on your own? Excuse me? Okay, good. All right, let's go down. So on number 29 through 33, what we're doing is we're just writing these as 1. So we're like going backwards here. All right, let's look at number let's look at number 32. Because 32 gets a little crazy. On 32, this is the log base 3 of 4x times 5y squared. And guys, we are squaring 5y, not just y, but 5y, right? So this is going to be equal to log base 3 of 4x times 25y squared. I'd love to tell you we're done, but not yet. This is actually going to be the log base 3 of 100xy squared. It's not that bad. There are worse things, right? Okay, do y'all want to see any more problems in this section, or do you think you can? Yes, ma'am. Natural log?
Yeah, natural log is different.
It's not different?
You have the E.
Well, we're not,
You have the E.
you don't, it's not any different. You just have natural log of, you bring the 2 down in front, so it'd be 2 natural log of x plus 4 natural log of y.
Yeah, but
It's the same thing.
when
Well, you're thinking about like solving. You don't. The natural log is the same as just the logarithm with a base of e. So it's just the same thing, except for everywhere here, instead of us writing log, you'd write ln, natural log.
Okay. 'Cause I
Okay.
thought it was
Yes. 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 Any questions? Okay. Yes. Your answer 431 would be log base 6 of 1/2 x. On number 30, what does the minus mean? The minus means that goes to the bottom, right? So let me see what you have here. So what's in the bottom? Perfect. That's all. You got it. All right. Any other questions here? I'm not wanting to do problems for you guys. I just want to leave you some problems for you to actually practice on your own. Does that make sense? Okay. All right. Let's look at 34. So let's solve this problem. How could we solve this? How could we solve this equation? Any ideas? 34. Do you guys agree with this method, 25 to the power of 1/2? We're having some technical okay, there we go. What? All right, so 25 to the 1/2 power is equal to x. And you know 25 to the 1/2 power is just the square root of 25. And that's x equals 5. Very good. Any questions? That was easy peasy, huh? All right, what about this next one? Very good. Yes, sir? Yeah, but I need you to use it for calculator purposes only. Okay? All right, the natural log of e to the x minus 5 is equal to the natural log of 12. And remember that since this has the natural log has a base of e, these cancel. And we're just left with x minus 5 is equal to the natural log of 12. Got it? Okay, so then this is x is equal to, excuse me, the natural log of 12 plus 5, which is what?
I'll put this in my calculator.
What?
This can go in my calculator.
This can go in your calculator. I would love for this to go in your calculator right now.
It was a question.
Right.
It can go.
Yes. Put it in your, do you see the natural log button? I think it's right underneath the log button maybe.
Oh, yeah.
You see? Okay. All right, so did y'all get 7.48? Cool. All right, let's look at number 36. So, excuse me. As you guys were saying, the natural log, it's just a special way of writing the log with a base of e. It's the same thing. Okay, so if we have a log base e, look, can we just rewrite this in exponential form, guys? So this is e to the 3rd power is equal to x minus 1. Are you with me here? So that's e cubed is equal, or I guess we could just add 1 to both sides and just get e cubed plus 1 is equal to x. Did you see what I did there? It's like the natural log of x is equal to log base e of x. These two are equal. Y'all know that? So I just rewrote this. That's all. Are you with me? Yeah. All right, any questions so far? Okay, let's go to number 37. So, oh, I'm sorry. What is the answer when you put that in your calculator? 21.1, is that what everybody got? Rounded to the nearest hundredth? 21.09, okay. Over here, subtract 3 and we get 5x equals 13. Okay, now on this problem, what we're going to do is we're going to take the log of both sides. Okay, and we know we can, when we write logarithms, what can we do with that exponent? We can put it in front. Very good. Excuse me. So then we get x log of 5 is equal to the log of 13. And how do we get log, or how do we get x by itself? By the log of 5. And we get x equals log of 13 divided by the log of 5. And what is that? Calculator. It's always good to practice putting stuff in your calculator, especially when we can check the answers to make sure that when you get home you're not just putting it in incorrectly. That was a really nice way of saying, everybody please put this in your calculator. Thank you for Matt putting it in his calculator. He said 1.59. Is that what you guys got? 1.59 with confidence. Excuse me. All right. Number 38 is the same way. Oh, I know what I want you to put in your calculator. So let's say this last problem we just did. We got 1.59. Can I check that answer? How could you check it? Plug it in for x. Why don't you try that? Try 5 to the 1.59 plus 3. See what you get. Well, did you remember to add, did you put this in your calculator? Did you forget to add the 3, Murphy? Okay, which is really close to 16, right? The reason it's slightly off is because we rounded. The reason it's not actually 16 is because we rounded, okay? All right, let's look at number 38 is the same problem as 37, right? You take the log of both sides, you bring down your exponent. Are you following along with me? Okay, I think we should do 39 though, because it's a little, it's the same thing, we just have to write it as a single logarithm first. To do that, that would be log base 3 of x to the 3rd power times 3 equals 4. And I'm rewriting this because we just usually rewrite that coefficient first, right? All right, so now where do we go from here? Any ideas? Excuse me? Yes, I heard someone say write it in exponential form. Could you tell me how to do that, Miguel? Write it in exponential form? Do you remember how to write it in exponential form from here? Okay. Could you help him out, David, writing it in exponential form? No? Okay, David, look at the top of your page. Do you see those problems? We wrote those in exponential form. Him, David. I'm sorry. Thanks for clarifying, though. Thanks for asking. So we start with our base. What's our base? 3, right? So it's the base to the power. What's the power? 4 is equal to? Good. 3x cubed. I don't know why the 3's are coming out that way. So where would we go from here, Miguel? It's just an equation, so we can just simplify it, right? So how do you simplify 3 to the 4th? What do you get when you... 81. So we have 81 equals 3x cubed. And how do you get the x by itself, David? Perfect. Divide by 3. And when you divide by 3, what do you get, John? Well, 81 divided by 3 is 27, and you'd know that if you put that in your calculator. And then what would we do next, Sierra? Perfect. Take the cubed root of both sides, and we get x equals what, Sierra? Okay? In your calculator, you can go there are different ways. You could go to math and go down until you see the cube root button. We also, do y'all see that way? It's 3, right.
Wait.
Oh, yours is different. So I think you press 3 and then you go second caret and then 27, enter. Yeah. If it were the 4th root, you'd press 4 first, okay? Do you see?
Yeah.
Okay, or another way we could do this, guys, is we know that x to the 3rd, or I'm sorry, we know the cubed root of 27 is equal to 27 to the 1/3 power, right? So you can put that in your calculator. Maybe try it. Try putting 27 to the power of 1 divided by 3, and that'll give you the same answer. You might like that better. 27 caret, open parentheses, 1 divided by 3, close. Do you have a question, John? You see?
So whatever.
It's the same answer.
Like,
If it were the 4th root, it'd be 1/4. Okay? So our answer is 3 here. Did we do 38? No. But we talked about it. We talked about how we take the log of both sides, and then just like in 37, you'd bring the exponent down. You divide both sides by the log that's over there, and then you just solve the equation for x. Okay? Do y'all want to do 40? Okay, how would I set up 40? Could you help me, Alyssa? Start this one off, please, ma'am. Okay, it's okay. Oh, I'll give you a hint. Start off by writing in exponential form. Do you remember how to write this in exponential form? Well, we'd start with our exponent, our base, which is 81, right? And we raise that to the power of, do you remember which one? The 1/4, very good. And then we set that equal to, perfect, 4x plus 3. Don't let the parentheses scare you. It's whatever was there is what we're going to set it equal to. Does that make sense? All right, so what's 81 to the 1/4? You can put it in your calculator, right? And what do you get? 3. So then we have 3 equals 4x plus 3. Subtract 3 and we get 0 equals 4x, so x is equal to 0. I'm glad that you guys are being very quiet, but I almost feel like you're not getting things when you're just too quiet. Do you have any questions? Questions? Thanks, Jada. That really sounded convincing. Appreciate that. Because they
Can we go over like 30?
what?
I went over 32.
You want to go over 32?
No, I said can we go over like 30 because you went over 32 really quickly.
Okay. So if this is minus, do you know? Well, first off, do you know what we do with this 4?
Yes, you put it. It's like it's going like it's.
Just why don't you tell me how you think you do this problem? I'll write it. You talk.
I'm not sure. I know that the 4 log 2 y is gonna go on the bottom.
But how do I write it on the bottom?
2.
We're done with this. We only write this once. So what do you do this 4? It goes.
Yeah.
So it would be y to the
4
good, and what's in the top?
x.
X, and we're done. See? Questions? Hold on, Daniel. Yes. Yes. Do you have another question, Murphy? What? Okay. You said 30? 38? What'd you say? Mm-hmm. Okay, this is the reason I don't want to go over 38 is not because I don't want to go over 38. It's because I want you to try to do it. Look right here at us going over 37. They're the same problem. The only difference is, do you see, we take the log of both sides, and then we bring the exponent down. That's what, see this, the x came down? You're going to do the same thing. You're going to take the log of both sides, and you're bringing the exponent down on 38. The only difference is on 38, the exponent is 4x plus 1, I think.
Yeah.
Do you see that? We still don't see that? Okay, I can do it. I want y'all to, you watching me do problems isn't going to help you as much as you doing them. So this is the log of 12 to the power of 4x plus 1 is equal to the log of 20. Okay, but remember when we write logarithms, we can bring those exponents down in front. So this becomes 4x plus 1 times the log of 12 is equal to the log of 20. So then to get 4x plus 1 by itself, we divide both sides by the log of 12. And we are left with 4x plus 1 is equal to the log of 20 divided by the log of 12. And if you wanted to, you can go ahead and put that in your calculator and get a decimal. But can you take it from here?
Yeah.
All right. Close the door, please. All right, y'all got it from here. We need to move on, okay?
Yes, ma'am.
These are pretty much the same problems. You would subtract 2, and then you get ln of 3x minus 4 is equal to 5. And then remember, it's e to the 5th is equal to 3x minus 4. Because the base of the natural log is e. Hello? Hey. No problem. All right. Any questions here? Okay. Hey, stop by Miss Hyde after you leave here, after the bell. Okay. Let's talk about rationals. Okay, let's start with these problems here. Okay, guys, do you remember what the holes are? Yes, what are they? Right, it's anything that simplifies. If you simplify something from on the top and the bottom, and they cancel. Yes, ma'am. So let's look at this. This would be x plus 2 divided by x minus 3 times x plus 2. So these guys cancel, and then that means our hole's at negative 2 because we set the factor that cancels equal to 0 and we solve for it, right? So that leaves us with y is equal to 1 over x minus 3. Are you with me? Now, the vertical asymptote is what we get when we set our denominator equal to 0. What is our denominator? And it's x minus 3. And we only find the vertical asymptote after we have found the holes. Is that clear? Holes first and then vertical asymptote. So vertical asymptote is going to be x equals 3. We'd add 3. See?
Yeah.
Not that should be a 3. Okay, now this is something you're going to want to write down because it's something you've probably forgotten. Our horizontal asymptote, that's where it gets a little crazy because we have those 3 different cases, okay? Case 1, if the degree of the denominator is greater than the degree of the numerator, do you remember this? Then it's the horizontal asymptote is y equals 0. Do you remember that? The second case is if the degree of the denominator is less than the degree of the numerator, then there is no horizontal asymptote. Did you see that?
Yes.
All right. And this is the third case. If the degree of the denominator is equal to the degree of the numerator, okay, it's y is equal to the coefficients, right? Just I don't know how to abbreviate coefficients. Any questions? You probably want to write that down because you're going to need that for all of these problems and the rest of them. And I still have some quizzes I have to grade for my other algebraic connections class. However, when I have an opportunity, I plan on going back through the study guide and kind of making a study guide for your study guide of, you know, what to do with these problems and what formulas you have to know here, just to kind of give you, because I know how hard it is when we haven't done this in 5 months, you know, 4 months. Yes, ma'am.
Number two, when the degree of the denominator is less than,
There's none. This should say maybe none.
yeah, probably
Not,
not act.
like there's not one. So on this first one, what is the horizontal asymptote? What's the, on number 53, Kevion, what's the horizontal asymptote? Is the degree of the denominator greater than, equal to, or less than the degree of the numerator? Well, it's greater than because the degree of the denominator is 1. Do you guys see this? And there's no variable in the numerator, which means if there were a variable, it would have a degree of 0. So 1 is greater than 0, which means the degree of the denominator is greater. And as we saw, if the degree of the denominator is greater, it's y equals 0. Does that make sense? Okay, so on number 2, do we have anything we can cancel out? We do, but we don't really have it until we factor out an x from our numerator. So that's x times x squared plus 3x plus 2 all over 3x. So our x's cancel, right? What does that leave us as a whole? What whole do we have here? Can you all identify the whole? Yes. 0. Do we have a vertical asymptote? No, because we don't have any variables in our denominator. And is the degree of the denominator greater, less than, or equal to the degree of the numerator? It's less than, and if the degree of the denominator is less than the degree of the numerator, guess what? No horizontal asymptote. Any questions? Yes, ma'am.
How come like when you cancel out the x's, it's not 2x?
Okay, no, I understand what you're saying. Do you answer your own question? Are you sure? Okay. Other questions here? All right, your homework is numbers, oh, that's a little too many, number 1 through 46. And, can I see that, please? Okay, wait. 53 through 58. Mm-hmm. 1 through 46 and 53 through 58. And I'll put that on Schoology. 1 through 46 and 53 through 58. And 1 through 46 is, I mean, we did 1 through 16 last night for homework. We did a lot of problems today. But you guys are going to have to start doing, please stay in your seats. Please stay in your seats. Hello? Okay. Yes. Okay. No problem. Thanks.